Sorry. If you're given the graph of a sinusoidal function, you can figure out the properties and then write the equation. Now, we've done some of these, but we're going to do this without a huge graph. Okay? So ask yourself what transformations will take you from y equals sine theta or y equals cos theta to the graph that you're looking at. So here you're asked to write an equation for each graph as a sine function and a cosine function. So very much like what we were doing before. All right, so it kind of, hopefully it helps a little bit. We just have to outline 4 different things in order to build this equation. So again, start by looking at your a value, trying to find the k value, etc., etc. So you do have to outline whether you want it to be a sine or a cosine graph. So since I've already actually done it, I'm just going to highlight my way through. So sine waves always start at 0, 0. So if it starts here, it goes up and down, so there's no reflection because sine waves always go up first and then down first. All right, so axis of the curve is on the theta axis, which means there is no vertical translation. So d value we already know is 0. All right, what we can do is look at amplitude. From 0 all the way up to the high point is 3, so we know a is 3. We also know, without doing any calculations here, that if it's starting at 0, 0, then c, there's no shift, right? If it's a sine function, no shift. All right, so the only last thing we need to do is determine what the k value is, and to do that we need to figure out the period length. So period length, it starts here and ends here. Well, if it's starting at 0 and ending at 180, then you have a period length of 180. So then you can calculate your k value just like we've been doing. 360 divided by 180 will give you a k value of 2. All right, so now you have all the makings to get your sine wave. So you've got y equals 3 sine, k value is 2, there's no c value, there's no d value. So this is the simple equation. Now, you also have to look at a cosine wave. Well, my cosine wave, I've circled my start points here, right? So my cosine wave is starting at its high point here. All right? So we need to figure out basically how far over that is. Okay, because the only thing that's changing between these two graphs is the phase shift. So if we know from start to finish is 180, from start to the middle is 90, so that means if this is halfway between 0 and 90, it's at 45 degrees. So it's at negative 45, and that's what you're putting in your equation. Notice everything else is the same except for the fact that we changed sine to cosine, but the phase shift is the only numerical value that's changing here. Everything else stays the same. Okay, and it's imperative that that happens. Okay, all right, let's move on to the next one. Again, you have to determine sine and cosine. Okay, so we'll keep yellow for sine. Sine's always starting at 0, 0, so this one also starts there. Now, we're not seeing the whole wave here. We're only seeing half a wave, so that doesn't help. You have to do a little bit of thinking there. But you do know that the vertical translation is still 0, okay? Your axis of the curve is still the theta axis. So, and you do know that your c value, the phase shift, there is none because it is starting at 0. You can figure out your amplitude because from the axis of the curve to its highest point, according to our scale here, it's a half. Always look at your scale. All right, so now we're down to looking at the period. Half of the graph takes 360 degrees, so double that and you've got your period length, okay? So 360 degrees divided by 720 gives you a k value of a half. So now you have your equation here. Your y equals a value of a half sine, k value of a half, c value is nothing, d value is nothing. Make sure that is a theta, okay? All right. if we're looking for the cosine starts at its high point, so there's your high point, and nicely, this is already marked, so you know it's 180 degrees to the right. Well, there's your cos, 180 degrees, and again, the only thing that's changing is that you have a change in the c value, other than the fact that you're changing sine to cos. Okay? All right, one more to go, I think. All right, so this one's a little different. You can see that there's a vertical translation already. So the one thing that you might want to do is find out where that is. Now I've marked it here, but you're at -1, you're going up to 5, so there's 6 from high to low, so halfway would be at 2. So at 2 is your axis of the curve. That's a little crooked, but you get the idea. So your axis of the curve here is at +2. So you can put that in here for your d value. Sine wave is always going to start on the axis of the curve. So here it's starting at 0, 2. Okay. Now, so that's all right. So there's no phase shift because it's starting right on the y-axis. Remember, you want to find your start points close to the y-axis. And again, you can look at your amplitude. If it starts at 2 and it goes to a high point of 5, then you know your amplitude is 3. The other thing to look at, the last thing to look at, is what the period is. So if it starts at 0 and it ends at 120, then your period length is 120 degrees. So if P is 120, put it into your equation, 360 divided by 120, so your K value is 3. All right, so writing your sine equation, y equals 3 sine 3 theta plus 2. Again, A value is 3, K value is 3, and the D value is 2. And again, no C value, so you don't need the double brackets. Now looking at it as a cosine function, and again, I'm choosing values that are the high point closest to the y-axis so that your phase shift values are small. So here, we don't know what that value is, but we can figure it out quickly. If the full wave is 120, half the wave is 60, and that means half from 0 to 60 is 30. So you have a shift of -30 or 30 degrees to the right to put in. And this creates a double bracket here because you have a K value and a C value. Make sure you have a double bracket, and yeah, now you can see it, and make sure you carry down all of your values. So your A value is the same, the K value is the same, D value is the same. The only thing that's changing is that you've got a different C value, and of course the difference between sine and cos. Very important to put those sine and cosines in there because that tells me what graph you're looking at and what start points. Again, circle all start points. In this case, labeling them like I have is a very good idea, okay? And it keeps you on track. All right, so you've got 4 questions to do from this particular sheet, and then you've got a couple graphs that you have to build the equations from. They're on 2 different sheets. They're attached to on OneNote here. So hopefully you shouldn't have much of a problem with that.